Year 13 short revision video number 30. So a curve has equation y equals 16x plus 1 over x squared. Now my first thought would be to rewrite that in this format here. And for one part A, we simply have to differentiate this and find dy by dx, which is of course 16 minus 2x to the negative 3. Then for part B, finding the second derivative, 16 differentiates to 0, and then this part here is going to differentiate to 6x to the negative 4. Now, for part 2, we know at any stationary points, dy by dx is equal to 0, which gives us 16 minus 2x to the negative 3 equals 0. So that tells me that 2x to the negative 3 must equal 16. That's 2 over x cubed equals 16. So 2 equals 16x cubed equals 1/8, and x equals 1/2. Now, that's the x-coordinate of the stationary point. The question asked us to find the coordinates of the stationary point, so we need to substitute this into the equation of the curve. So back up over here, and that gives us a y value of 12. And then we need to determine the nature of the stationary point. There are lots of different ways in which we could do this. We could look at the derivative either side of the x value and see what the sign change is, or we could simply use the second derivative. So d2y by dx squared is equal to 6x to the negative 4. We worked it out over here. So at our x value of 1/2, d2y by dx squared is equal to 6 multiplied by 1 over 16, which comes to a value of 3/8, which is obviously greater than 0, so we are clearly dealing with a minimum point here.